Once you know how to program, picking up a language is easy, and it's why anytime I teach a programming class, I know that most of you are watching this to learn how to code instead of learning about the language. For that reason, I often use the analogy what if you were enrolled to a cooking class, you will first need to know the kitchen. Understanding a programming language is learning the tools in the kitchen. This is a chicken and an egg thing. To start cooking, you will need to know where the ingredients are and what are the tools available in the kitchen. Today we're going to go through the basics of the Java programming language. Programming is about solving problems, and the good news is that you already know how to code. The only thing is that you need your brain to be not as quick and to stop and break down the step-by-step instructions to give them to the computer. For example, if I gave you this list and I asked you to sort it, you would know exactly how to do it pretty much immediately. But if I asked you to write the code for that, you might have to stop, think, and most likely you would skip some obvious step that you would discriminate because they were too obvious to tell. My goal is to help you translate the programming you already know in your head into your computer. Well, why Java? According to GitHub's Octoverse 2018, Java is the second most popular programming language in the world, right after JavaScript. There's no denying that Java is still one of the most important languages to this date. It quickly rose to power in 1995 after it promised code that it could be written once and run everywhere. Java's designer James Gosling aimed to solve the problem that most complaints that C or C++ programming dealt with, like reducing the complexity in multi-thread programming, making memory management easy, memory isolation, portability, speed, and good error handling. Given that every cycle of CPU power was sacred in 1995, there was a big effort to make it as fast and as efficient as possible. In some cases, a program written on Java is as fast as a piece of code written in C++. Platform versatility and speed is a good reason why the creators of Android used it to support as many phones and devices as it could. Java compiles code to bytecode, a universal language interpreted by the Java virtual machine. The bytecode or class file can be distributed because a native virtual machine will be interpreting the bytecode, acting as a translator to the commands of the host machine. In other words, each architecture speaks a different language, and the Java virtual machine knows how to talk to each one of those individually. Java will provide, Oracle or whatever developer that created Java will provide the direct link to those machines. So you only have to worry about your communication between your code and the virtual machine. Java, like many programming languages, are based on being a collection of statements. Each statement is an instruction to the computer. A statement will look like this, or simply this. A collection of statements that is surrounded by curly brackets is called a block, just like this. And within a block, scope is a concept that defines visibility and lifespan of a variable or value to sibling statements. It is important to know that the computer is reading instructions top-down, so a statement referencing a variable defined after the execution of the current line won't be visible to the current statement. In other words, the virtual machine cannot predict what is ahead of the line that we are currently reading. It is also important to know that once a block of code is closed, the variable is destroyed and no longer in memory, ending effectively its scope. So in the previous code that we had written, the scope of this variable, my variable, ends at the time that these brackets are closed. So if I try to access it, my variable, and try to increase it again, I'm going to get an error of the compiler because it cannot resolve who my variable is. But if I cut and paste this thing here, it actually recognizes it. Why? The reason is simple. When it started this block, anything that was above here, so for example, if I did int my other variable, it is 50, and then I call it from here my other variable plus plus, it would actually increment that variable. But the reason why this one is gone is because the block closed right here as opposed to keeping that variable available. So that's how the compiler keeps memory management in check, by just making sure that things that are available through the scope, this block can read anything that it's on the parent scope, but it can also only read the things that are in its own scope. Outside of that, things are not available. Like every programming language, Java tries to define the world via primitives, or collections of primitives that are effectively objects. The computer only understands zeros and ones, on or off. And from that, internally, it has it uses those zeros and ones to represent data that we can understand and communicate with the computer. So what we're going to see in the third column is the amount of bits or on or off switches that are turned on, how many switches it requires for this data type to exist. In the case of a Boolean, which is true or false, it's only 1 bit, which the value is only 0 or 1, which is very intuitive as 0 or 1. In the case of a byte, which is 8 bits, that represents binary data, such as, for example, the contents of a JPEG file or the contents of an MP3. Those are binary data, and Java represents them as a byte, which the range of the data is whatever 8 bits can handle. Then you have characters, which represent letters, so that way we can understand letters with a computer. In Java, a character is using 4 bytes, and that is also has to do with Unicode. That's the reason why it's bigger than other languages, but it's more than enough characters to represent everything that we need to represent. With the case of double, it's a very precise number. It's a double precision number. That's why it's called double precision number. Means that, for example, if we want to represent pi, we can do it by using 4 bytes, which 4 bytes is a lot of data, because the range of a double can go from 9 quintillion to minus 9 quintillion to plus 9 quintillion. So it's a really a lot of space allocated for representing very, 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 very precise numbers. A float is a smaller version of a double. So in case that we don't care too much about precision or things like that, float will be really useful because it will let us just represent with less memory. And when you're dealing with like programs, you know, when you're dealing with something small, who cares if you're using a double or a float? But when you're trying to create, say, an array of millions of float values versus millions of double values, well, basically you're duplicating the memory, so you can hold more data in an array of floats if you really don't care about the precision of the type. The next one is an integer, basically a number, a regular number, 1, 2, 3, 4, minus 1, minus 2, and the range, because it is 4 bytes, it goes from minus 2 billion to plus 2 billion. A long is a very long number, similar to a double for floating point numbers. A long is the longer version of int, and it's using 8 bytes. And a short is an even shorter version of an int, which goes from minus 37,000 to plus 37,000. The combination of all these objects, along with other with structures and things like that. So, for example, an object that wraps an array of characters is a string. An object that wraps an integer, it's called integer, and so on. We're going to be reviewing more of these as we go forward with the class. A variable is a label that we assign to a value. To keep things simple, a variable can hold one of the 3 values: a primitive data type, an object, or a null value. Java is a statically typed language. That means that Java likes its variable and methods to stick to the data type that it was defined as. Anything other than that will make the compiler unhappy. Statically typed means that once you have declared a variable, you cannot change the data type. So for example, this variable that we called my other variable, I cannot just reassign it to a float, because the compiler will say that the types are incompatible. We had a required int and it found a double. So statically typed means you gotta be consistent with the data type that you required and that you're assigning. One important thing is that Java is object-oriented by design, so everything will be a class, even if the class is just used for the main method. The main method, historically, is an entry point that the program in this case the JRE or the Java runtime, looks for and starts the execution of code. A program, when executed via the command line according to the POSIX standard that covers Unix-like systems like Linux, Mac OS, BSD, has 3 file outputs where the program interacts with. The first one would be standard in, which is the input via keyboard. The second one would be standard out, which is the output of the program. The last one would be standard error, the output of error messages used to not clog the main screen where it captures the main output of the program. In case that an error needs to be fixed. So for example, we can throw warnings into standard error and capture those offline without distracting the user. Operators are the things that make the computer process something at the very basic level. So we have logical operators like AND, OR, XOR. So for example, we can say, I would like pizza and soda. That is an AND operator. Or I would like to say we have available pizza or pasta. That is an OR operator where both conditions don't happen at the same time, but as long as one of those happens, then that is true. In the AND operator, both conditions need to happen at the same time. There are also arithmetic operators, which essentially perform just basic math. For example, the plus, minus, divide by, and multiply and modulo operators are the ones that perform numbers to do something with it, or operations that we're familiar with in math. Operators tend to have an order of preference or an operator priority. So if we looked at the code that we wrote before, and we actually say that our code could be something like 100 plus 2 times 10 divided by 4, and then what is this operator going to do? If we start processing like just regular humans, not supercomputers, where we do these guys, then as we are reading it, something like this would be the from left to right reading it would be 100 plus 2, that's 102 times 10 divided by 4, which would mean that it is 255. But if I were to run this code, we will find the surprise that the code is nothing like this. It is actually 105. The reason is because there's this order of priority that operators have, such as this guy. So that means that in this table, the operator precedence is whatever is the highest, it's applied first. Low ones is at the very end. So the assignment happens at the very, very, very end, and then math operators happen before, then logical operators happen as a second priority. Where increments or decrements are the first thing, then multiplication and division, then addition, then regular comparisons, and then logical operators. So for example, this operation, by saying that this, how does it get to 105, is that we're going to say that in reality, that it's going to multiply it. So we have 20 plus 100 divided by 4. So what is then going to happen is that this guy is going to be then applied, which is going to be translated to 5, and then the total is going to be 105. Very different. So if you want to make sure that the operations that you're doing are performed in a specific order, the main thing is to add parentheses around them, so that way that you can do it at the way that you were thinking about it. So for example, this is going to convert these into 102, then multiply by 10, then divided by 4, which is going to bring us back to our 255. Another important thing in Java is control structures. In control structures are just a command that allow us to direct the traffic on the code. So the most typical ones are the ones about flow, like if else. If let's say my variable greater than 10, then let's say system.out.println is going to be greater than 10, else you can then do something like not greater than 10. So whatever in the structure of the if, whatever is between the parentheses needs to resolve to a true or false. Now let's talk about loops. Loops are things that repeat themselves while a condition is being met. So the most popular one is a for loop. And a for loop consists of three parts that happen between the parentheses. The first one is the condition that defines the starting point. The other one is a condition that will resolve while resolving to true, it will continue to stay in the loop. And then the third one is the increment that it should happen. This is really useful for building counters. So for example, if we have this loop, it will print 10 times what the counter is in our code. So it printed count 10 times starting from 0 to 9. Another one is a while. And a while is different than a for in the sense that it doesn't have a counter that it's necessarily there, but you can actually execute it outside of the counter. So you can define the initial condition outside, int I equals 0, while I less than 10, and then inside of the loop you essentially put those three things. This is exactly the same as the previous for loop, and then you can do the same code just above that line. So if we run it, we're gonna get the exact same output. There are other ways of simplifying, because in a for loop, because let's assume that we have a string array and we'll say hello Java students, and we want to iterate over that. We want to just not have to, our alternative, and this is to have to go int I equals 0, I less than myvar.length, and then I plus plus. And then if we want to, we have to want to print, we have to essentially index each element on the array. That's with the tools that we know, but it's kind of not ideal. It's not pretty, because you have to be initializing this other variable, and it doesn't make it readable. So what we're going to do is that we're gonna say that we're gonna unpack a string for each element of the string. So we're gonna name it item in myvar, and then if I go and do item, it's making it simpler, because I am saying this semicolon is saying for each string item that lives inside of myvar, just print it. Makes it a little bit cleaner and a little bit simpler, which is a cool thing to know. A couple of important keywords that happen inside of loops is the keyword break and continue. So the keyword break, what it does is that it's going to exit out of the loop, and then the keyword continue is that it's going to go to the next item in the list. So for example, if we say, let's start from this entry point. So we can say that we're going to skip the word hello, and we say if item dot equals hello. I want to actually point out here that I am not doing item equals like that, and the reason is because when you have a string and it's doing that to hello, it's going to compare a different string to another different string. So it's going to compare the two objects. Obviously, the two objects live in different memory spaces. So this is going to yield a false. So what we do is that we use the dot equals method inside of the string, because that way we're comparing the contents of the string. So if the item equals hello, we're going to continue. We're going to jump to the next one. So essentially, we're going to just print Java students. What would happen if I would say break? Instead, it would actually exit the loop. And what would mean is that it wouldn't print absolutely anything. This is really useful for allowing us to not perform operations on really big arrays, and it's really useful for performance. I hope you found this Java refresher useful, and now let's jump right into the examples. And in the meantime, you can just subscribe to this channel, and I'll see you next time.